A lot of people say that the first step to solving a problem is admitting that you got a problem in the first place. Well, this is math class, so we've got lots of problems. So our first step to solving them is to be able to express what the problem is. My name is Ms. Danielson, and today we're setting up simple expressions. Let's get started. Let's start out with some vocabulary so that we have the words to express ourselves. But when I talk about expressions, I'm not talking about words. I'm talking about algebra. The use of letters or symbols in the place of unknown values in a calculation. So today we're looking at algebraic expressions. Variables are the letters or symbols we use in these algebraic expressions or in equations that take the place of unknown values that we would need in order to perform a calculation. Expressions, which we're looking at today, are algebraic statements. If we knew the value of the variables, we could complete the calculation and get a numerical answer. But if we don't know those values, all we can do is write out the calculation that we would do and simplify it as much as possible so that we're ready to make that calculation once we find out the unknown values. Terms can be numbers, variables, or a combination of both, like 5x or x squared, for example. You should be able to distinguish the different terms in an expression by the separations, being a plus or a minus sign, so we never want to leave those out. If you're new to algebra and expressions, function machines is a great place to start because it's a way of expressing the operations you're going to perform on some value or variable without needing to write any algebra out. Functions or operations like plus, minus, multiply, and divide, or also powers or roots, are ones you should be familiar with. We're just going to focus on the first 4 functions. For example, here's my function machine. It takes some input value and performs these operations on it and gives me an output value. If I put the value of 5 into this machine, for example, the function machine tells me to multiply whatever value I put into it by 4. So 5 times 4 is 20. And then take that number and subtract 7 from it. 22 away 7 is 13. And that was the last operation of my function machine, so my output value would be 13. Now my output value always depends on what my input value is. So suppose I input 2, I will perform the same operations on my input value. First I'll multiply by 4, that'll be 8. Then subtract 7, that'll be 1. So my output value is different. Now my output is 1. Let's try that with one more input value. If I input -3 into my function machine, then I'll multiply it by 4, so that's -12. I'll subtract 7 from it, so it becomes more negative, -19. My output value is -19. Now this last example is where I'm going to input a variable. If I put x into this function machine, my function machine will perform the same operations. It will multiply x by 4, which would give us the expression 4x. A number in front of a letter means the number is being multiplied by the letter. Next, we subtract 7, so 4x minus 7. Our output value is actually an expression. When you put an expression or a variable into a function machine, you can expect to get an expression or a variable as your output. You shouldn't expect to get a number value as your final output if you don't put a number value as your input. So our output is 4x minus 7. Here's a couple more examples. Let's write some expressions out of these function machines. So input some variable, let's say x, into this first example. Our machine tells us to divide the input value by 2, and I prefer to write that as a fraction. We should generally get used to this. So x divided by 2, I write as x over 2. Then I subtract 4 from that. That's x over 2 minus 4. Pretty straightforward, I hope. Let's try it with example B. Again, I'm trying to write an expression, so I'll input some variable, some letter. Let's try y. And I'll perform these operations on that variable. I want to subtract 7 from y, so y minus 7. And then I want to divide this answer by 3. Now using a fraction for that should make this a lot clearer. I'll do y minus 7 and divide that answer by 3. So y minus 7 over 3. Last example, again, I'm trying to write an expression, so I'll use some variable, let's say z, and I'll perform these operations on that variable. So adding 3, z plus 3, and timesing by 3. Make sure you maintain the order of operations here, because in BEDMAS order of operations, usually we would do the multiplication first, but this function machine clearly wants me to add first. So I'll put brackets around what I've got and multiply by 3. So 3 bracket z plus 3 would force me to work out what's inside the bracket first, so do the addition first, and then multiply my answer by 3. This expression can be simplified by expanding out the brackets. If you're not familiar with expanding brackets, check out the description box down below. I'm linking a lesson for you there. To expand these brackets, I'm multiplying the 3 by all of the terms inside the bracket. So 3 times z is 3z, and 3 times 3 is 9. So 3z plus 9. Both of these are equivalent expressions, but the second one is simplified. Let's try an example where we turn words into expressions now. And this is a skill that we are really building ourselves up to, because this is what you need to be able to do in order to solve word problems. Let's start with a simple example. I think of a number and I add 7. Then I divide that answer by 4. Write this as an expression. In order to write an expression, we need to start by identifying the variable or the letter that we're going to use to represent the unknown number. So in this case, I think of a number. Let me use x to represent that number that I first thought of. And then I can perform these operations to x. So I think of a number x, I add 7 plus 7, and I divide that answer by 4. X plus 7 over 4. Now that's my expression. Simple, right? Let's try another one. Here's an actual word problem that you might need to solve at some point. A family of 2 adults and 3 children buy tickets for the cinema. Write an expression for the total cost of the tickets. They're not asking us to work out what the total cost of the tickets is. That would be impossible because there's information that we don't know. Our first step to writing this expression is to decide what information do we need in order to calculate this. To find the total cost of the tickets, well, I would need to know how much the adult ticket costs and how much the children's ticket cost. I know how many adults and how many children are going, but I don't know how much each ticket costs. So let's write a let statement to identify the variables or letters that we're going to use to represent these unknown numbers. So I'll let A equal the cost of an adult ticket. And I'm being very clear to write a sentence here about what A is. I don't write A equals adult because that might be confused with A equals the number of adults. I know how many adults there are, I just don't know the cost of each ticket. I'll also let C equal the cost of each child's ticket. Again, I know how many children there are, but I don't know how much each ticket costs. So now I can write my expression for the total cost of the tickets. That's going to be 2 times the price of an adult ticket plus 3 times the price of a child's ticket, because I'm buying these tickets for 2 adults and 3 children. Now to take that one step further, suppose we know that the cost of an adult ticket is twice the cost of a child's ticket. Let's write a simplified expression for the total cost of the family's tickets. When we're writing an expression, it's generally best to use as few unknown variables as possible. So that way we can simplify it, and once we find out how much a child's ticket or adult's ticket cost, we could actually work out the total cost. So if the adult's ticket costs twice as much as the child's ticket, I'm going to replace the A in our expression with 2C, because A, the cost of an adult ticket, is equal to 2 times the cost of a child's ticket. So 2 adults will have to pay 2 times twice the cost of a child's ticket, and 3 children will pay 3 times the price of a child's ticket. Simplifying that, I'm doing 2 times 2C. So that would be 2 times 2 number times number is 4. That's 4c plus 3c. And simplifying that again, grouping our like terms, we're talking about 4 times the cost of a child's ticket plus 3 times the cost of a child's ticket. That would be 7 times the cost of a child's ticket. This is now fully simplified. As we said in the beginning, we don't know how much the child's ticket costs, so we can't solve it. All we can do is write an expression that is simplified as much as possible. Let's go through one last example together before we start our practice exercise. And this example is very similar to one that you're likely to find in your textbook. A sweet shop sells boxes of sweets in 4 different sized boxes. Each size box is a different color. So the different box sizes or colors are red, green, blue, and purple. The red, green, blue, and purple boxes will have different numbers of sweets inside each of them. Let's write a simplified expression for the total number of sweets in 4 red boxes, 2 green boxes and 4 purple boxes, 2 full blue boxes, and 8 green boxes which are only half full. Now this may look a bit confusing because there's a lot of things that we don't know in this question. Let's start by identifying what information we need in order to calculate this. If I want to find out how many sweets are in 4 red boxes, I know how many boxes there are, but I don't know how many sweets there are in each one. So let's make our let statements to identify the variables, that is the letters that we're going to use to represent the unknown numbers. So the unknown number of sweets in a red box, green box, blue box, and purple box. Make sure your let statements are clear. So full sentences, please. Let the following represent the number of sweets in each of these colored boxes. Not the color of the box, not the price of the box, not the weight of the box, the number of sweets. R equals the number of sweets in red boxes. G equals the number of sweets in green boxes. Blue equals the number of sweets in blue boxes. And P equals the number of sweets in purple boxes. So writing that let statement before I introduced my variables made it easier for me to describe. So for part A, 4 red boxes would have 4 times the number of sweets in a red box. That's just 4R. Simple. Maybe you want to hit pause and try the other 2 for yourself before I give away the answers. For B, the number of sweets in 2 green boxes and 4 purple boxes, well, that would just be 2 times the number of sweets in a green box, plus 4 times the number of sweets in a purple box, 2G plus 4P. Simple. And question C, 2 full blue boxes, so 2 times the number of sweets in a blue box, and 8 green boxes, but these green boxes are only half full, so 8 times half of the number of sweets in a green box. 2B plus 8 times a half of G, or 0.5 G, and we need to simplify whenever we can. 8 times a half G, we'll do number times number. 8 times 0.5 is 4. So 2B plus 4G. And I can't simplify that any further because they're not like terms. We can't group B with G. So if that's all clear, we're ready for some practice. If you need help, leave me a comment or let me know. For question 1, I want you to turn these function machines into expressions, and I've told you which variables to use. Use variable A for the first one and B for the second one. For question 2, I want you to think of a number, double it, and then subtract 8. Use X as your variable and write this as an expression. For question 3, write an expression for this word problem to find the total cost of 3 large pizzas, 1 medium pizza, and 2 small pizzas. For question 4, again, turn this word problem into an expression for the total number of seats on 3 buses and 2 trains. And for question 5, given that W, that variable, represents a number, and it's the total weight of 15 players on a football team, write an expression for the mean weight of the players of the team. I hope you remember that mean is the average, and I hope you know how to work that out. Go ahead and hit pause now, copy the questions, show you're working, and make sure the answer is as simple as it can be. and hit play when you're ready to take it out. I hope you had a chance to hit pause, because here come your answers. For question 1A, our expression, but that can be simplified. First we added the 5, so that's in brackets. Then we multiplied that answer by 2, and then we subtract 7 from that answer. We can expand these brackets out, however. If I'm doing 2 times the bracket, I'm doing 2 times everything inside the bracket. That's 2 times the A, which will be 2A, and 2 times the 5, which will be 10. And don't forget we need to subtract 7. Again, we can simplify that further, grouping like terms. 10 minus 7 is 3. So our simplified expression, 2a plus 3. For part B, my expression, first we're multiplying by -2, so -2 times b. Then we're adding 3 to that answer. And then you want to divide the whole thing by 2. So it's easiest to write that as a fraction. You might want to write that the other way around. Generally, we like to start with a positive number, so you could have written that as 3 minus the 2b over 2, but either way is perfectly fine. For question 3, first I hope you made a let statement to make it clear. I used the letters L for a large pizza price, M for a medium pizza price, and S for the small pizza price. And my expression, it can't be simplified because they are not like terms. Don't group them together. Question 4, again, our let statement. We don't know how many seats there are on a bus or how many seats there are on a train, but using these variables, we can write the expression. And question 5, I hope you remember that a mean is the total divided by the number of values. So if we're given the variable W is the total weight of the 15 players, divide that by the number of players, dividing by 15, sharing that total weight out evenly. That'll give us our mean average weight. So this should have given you a good introduction to setting out expressions with a nice variety of different types of questions. Now, obviously, our expressions could get a lot more complex than these ones, but if you're having any trouble here, you're going to need to let me know before we move on to. Until next time, keep practicing, and I'll see you soon.